Eutrophication is the process that occurs when a body of water contains too many nutrients, most commonly phosphorus and nitrogen. These nutrients are typically very beneficial when they are present at normal levels because they aid in the growth of cyanobacteria. However, too many nutrients causes this organism to grow at a rapid rate and become dangerous to the health of the environment. Cultural eutrophication is defined as this same process, but it is the result of anthropogenic activity being the main contributor to the excess nutrients in the water. This disruption in the environment is what leads to dead zones, which National Geographic Encyclopedia defines as low oxygen or hypoxic areas in the world's oceans and lakes. Oxygen is a basic necessity for most organisms' survival, so when cultural eutrophication occurs and creates these dead zones, very few organisms are able to withstand the hypoxic conditions. As a result, these areas are appropriately named dead zones due to the very low survival rate of organisms in or around them. It is hard for one to argue against the importance of this environmental issue given that the aftermath entails environmental degradation and loss of abundant organism life. However, finding an unflawed solution for the problem is not as simple.
Probably wondering what we can do to fix this spreading issue. The first solution that our group thought was plausible was integrated pest management, or IPM, along with other farming practices. Based on our findings and our sources, farms along the Mississippi River, specifically farms in Illinois, contribute heavily to the nitrate and phosphate levels in the Mississippi River basin, which leads into the Gulf of Mexico. These high concentrations of nutrients serve to accelerate the problem of dead zones from cultural eutrophication in the Gulf. But IPM will lead to reduced levels of nitrates and phosphates in the Gulf because instead of just inorganic fertilizers and pesticides being used, other farming methods like cover crops, buffers, and conservation tillage help stimulate and promote growth of crops for farming industries. These farming methods encourage the use of non-chemical methods over chemical, so it decreases contamination and runoff. In addition, riparian buffers specifically help to reduce nitrate and phosphate release into the Gulf of Mexico. Buffers have been defined by leading experts as a complex assemblage of plants and other organisms in an environment adjacent to water. According to one study conducted by Center for Watershed Protection, nitrogen levels were reduced by 95% in Minnesota when they implemented riparian buffers. If riparian buffers are implemented alongside of IPM by Midwestern farmers, it has been proven by many sources that dead zone reduction in the Gulf of Mexico will occur. Although this solution seems highly effective to reduce dead zones from cultural eutrophication, it has several limitations that could reduce its use among farmers and agricultural businesses. For one, it is more labor-intensive and requires more careful application than just using inorganic fertilizers and pesticides. Since farmers will have to combine several methods of pest management, they'll need to know when to use each step of IPM that best gives them the results that they want. If farmers just continue to use inorganic fertilizers to boost productivity, they would not have to make those decisions. However, it would end up costing farmers more money in the long term if they did not switch to organic farming methods. In addition, the other farming methods have some limitations as well. Riparian buffers would also be more labor-intensive and costly to farmers up front, but besides the cost of upkeep of the buffers, farmers would not have to pay for the buffers again for several years after they establish the shrubbery and trees along the water. Furthermore, farmers will have more productivity and better crops if they employ the buffers, conservation tillage, and nutrient management because there is less nutrient loss, soil erosion, and ultimately improves water quality like in the Gulf of Mexico, according to the Science Education Resource Center at Carleton College.
Methods to reduce fertilizer efficiency, like planting cover crops, are beneficial in fighting the issue of cultural eutrophication, but when those methods are combined with wetland restoration, studies led by the Environmental Defense Fund have found that nitrogen pollution in the Mississippi River and Ohio River Basin can be decreased by roughly 45%. This 45% is also known to be the Environmental Protection Agency's target number that they believe is necessary to reduce the Gulf's dead zones to a manageable size. Given this information, we have come to our second solution for reducing cultural eutrophication in the Gulf of Mexico, known as wetland restoration. Wetlands aid in the process of decreasing dead zones by acting as a natural filter for bodies of water and runoff before it even enters the Gulf, and when placed strategically on as little as 1% of the land, the Journal of the American Water Resources Association found that they are able to reverse the trend of erosion and drastic loss of aquatic life. This solution has a number of benefits, one of the largest being that it's natural. Wetland restoration requires no machinery in order to clean and filter the water, and on top of that, it can provide additional habitats for various kinds of organisms. However, when considering using wetlands as a solution to cultural eutrophication, it's important to remember that this method works best when combined with other agricultural methods. So, by itself, wetland restoration may not be the most beneficial, given that applying multiple methods at once is more time-consuming and expensive. In addition, author Maria Kelmis argues the points that wetlands are not able to treat highly toxic modern wastewater. In other words, if the runoff is already majorly contaminated, then wetlands are not the most realistic method because they would not be able to adequately filter the nitrates and phosphates from the water before they connect with the Gulf. These reasons, combined with the fact that wetlands also account for approximately 1/4 of the Earth's atmospheric methane through the anaerobic decomposition of organic matter, lead us to believe that wetlands' limitations could possibly outweigh the benefits.
So one more solution that can help reduce dead zones in the Gulf of Mexico is to manage human and livestock waste runoff from farms and houses near the Mississippi River. Just like inorganic fertilizers, human and livestock waste is rife with nitrates and phosphates, and they too strengthen the severity of the hypoxic conditions in the Gulf. However, if farms and other establishments near the Mississippi could manage their waste better, the severity of the hypoxic conditions would decrease. According to the Science Education Resource Center at Carleton College, waste can be managed on a small scale by the farmers themselves through monitoring septic systems to reduce the discharge of nutrients in the groundwater and runoff. In addition, the same source mentioned limiting the discharge of nutrients, organic matter, and chemicals from sewage treatment facilities because farms are not the only sources that contribute to this issue. However, just like the other conditions, there are some limitations to managing the waste from farms and sewage treatment facilities. For one, there needs to be laws in place on the industry, and the laws need to be regulated to ensure that the waste from these establishments actually has reduced nutrients and organic matter. In addition, the facilities need to be monitored regularly for the same reason we already provided. But if these regulations fail, there also needs to be a system in place that can effectively clean up the toxic runoff, like drainage ditches or riparian buffers. If these limitations can be overcome, the waste management would provide reduced nutrients in the Gulf of Mexico and economic opportunities for people that regulate the waste facilities. Although this does not have much of an impact on the Gulf of Mexico like other solutions we provided, it is still a feasible and viable one to reduce the dead zones. So which solution would be the best one to reduce dead zones in the Gulf of Mexico? Well, the first solution, which was integrated pest management, is the best one to reduce hypoxia and dead zones in the Gulf of Mexico, because out of all the solutions that we presented, this one is the most manageable to do, and it has the biggest impact. The abundant nitrates and phosphates in the inorganic fertilizers that farms use causes algae blooms and ultimately dead zones from the hypoxia in the water. Although wetland restoration and waste management will help reduce the severity of dead zones in the Gulf of Mexico, and they should still be implemented, IPM and other farming practices that we discuss will have the most impact on dead zone reduction because of the farms along the Mississippi River are contributing most to this issue.